When working with signed numbers, not only do you have to learn how to add and subtract, but you also have to learn how to do multiplication and division. And when we start looking at all of the various rules that we have to follow, sometimes one gets a little bit intertwined with another, and before you know it, we're really not sure exactly which rule applies to which operation. So I'm going to try to make multiplication very, very simple for you. I want you to think about negative signs. I'm talking about the signs that you see on negative numbers as being socks. And with most people, it is true that when we have a pair of socks, that's usually thought of as being a good thing. And when we have individual socks, that's not quite as good because most of us have 2 feet that we have to cover. So with that as a premise, let's just go ahead and look at some examples of multiplications that are occurring between numbers, whether it be 2 numbers or 102 numbers. And let's always keep in mind that the actual sign of our answer is dependent upon whether or not our socks are in pairs. I think it's important that you be able to apply a concept first and actually see how it works, and then be able to go back and then later formally say, okay, this would be the algorithm or the rule that I would use to describe exactly what I'm seeing, and then be able to fully understand why the algorithm is exactly the way it is. So in an informal look at multiplication, I'm going to give you 4 numbers to multiply together. I'm not going to talk about 2 numbers at a time. You know, I recognize that when we multiply, technically we only multiply 2 numbers at any given time. But the issue with signed numbers is that students usually make mistakes with the sign of the answer. It's not the fact that they don't know how to multiply together numbers like 2, 1, 3, and 4. The problem is when they're multiplying together numbers like -2, -1, -3, and +4, quite often they make a mistake on the sign of their answer. So this is what I'm going to tell you. I'm going to say count your socks. I have 3 socks here because I have 3 negative numbers. We don't worry about the positive number. A positive number in multiplication can never lead to a negative number. Only a product involving a negative number or negative numbers can lead to a negative outcome. So the only thing I need to do is just say, well, I've got 3 negatives, that's 3 socks. I've got 1 pair, but I have a leftover. That's a bad thing. And because of that, I know that my answer is going to be negative. Make sure that you write that down. Wherever you're going to intend to write your final answer, make sure you write that negative sign down to say or to remind you this answer is negative. Now we'll go ahead and multiply together the numbers 2, 1, 3, and 4. That's a total of 24. Therefore, the answer to what is -2 times -1 times -3 times 4 is -24. And you see, I thought about this in 2 separate steps. I wanted to break this apart. Make sure I know what the sign of my answer is first, and then move on and talk about, okay, so what's the actual number associated with that? If we can overcome the problem that students have with, and in most cases it's carelessness regarding positivity and negativity of their answer, if we could get past that point, I think the majority of the issues that students have with signed numbers is just going to go away. It's going to go away because if we focus on this as 2 separate operations, and in a sense it really is 2 separate operations. You know, that may be the whole trick to understanding math, is being able to break it down into the smallest pieces we can, not trying to do as much as we can at one time. And if I'm able to go in here and count socks, as silly as that sounds, and I realize that in this set of numbers or this series of numbers I have 6 socks, that's an even number, they're coming in pairs, that means my answer or my outcome is positive, then all I have to do is multiply the numbers together. And then I quit worrying about forgetting or misunderstanding the sign of my product. And by the way, it works the same thing with quotient. When you're dividing, of course, you will only have two numbers at a time, so therefore you'll either have a pair of socks or you won't. Now make sure you understand that when we have a positive number, we're already telling ourselves, hey, that's a pair of socks. I don't even worry about that. Those have already been taken out of the dryer. They have been folded together and they've been put in the drawer. A positive number by itself cannot force a product to be negative. It's only the negatives, and I can determine that by counting the number of negatives in the product. So we can go ahead and project a use for this later in the future. This will help you to better understand about taking numbers, especially negative numbers, by the way, to different powers, whether those powers be even powers or odd powers, now becomes very important, because the true meaning of an exponent is the number of times that a particular factor or a particular base number is going to be used in a product. And so I'm using the example of negative 2 to the 7th power. What that relates to is the fact that I'm going to be multiplying the number negative 2 over and over and over again. I'm going to see a series of negative 2's lined up, 7 of them in a row, and looking for the product of that. What's the very first thing that you can tell me about the sign of the answer? Remember, we're saying we're going to line up negative 2 7 times in a row in a product. What does that tell you? Well, if you said the answer is negative because the number of socks that I have is an odd number, you're absolutely correct. I can only pair up 3 pairs and I have a leftover, so that's a bad thing. Now that I know my answer is negative, I can go ahead and say 2 times 2 7 times, 2, 4, 8, 16, 32, 64, 128, but knowing full well that the answer is going to be negative. And you can expand on this. This leads to an algorithm. When a negative number is raised to an odd power, the outcome is negative. If it were raised instead to an even power, the answer would be positive. So, it's not just two numbers at a time. Sure, if I multiply together two negatives, I get a positive. It's real easy to quote that. It's real easy to forget that later. But now when I start thinking about negatives as socks and pairs and this being a good thing, then I probably am never going to forget the rule for multiplying and dividing positives and negatives.